Hey! Make some noise, please. I'm dying without the coffee. I really need your noise. Really. Let's create some good energy. No. No, I'm not even gonna start. Make some noise, really. It's evening. It's like a 4. Yes, let's generate some good energy. Woo, I'll help you. That's how it should be. Thank you. Now much better. So, my friends, why I'm here? So, who I am? First of all, I'm Edward. I came from Latvia, small country, but fantastic country indeed. So we came together with Andrei. So we rock. Why I'm here? I'm going to tell you a few stories. Not more than that, just a few stories about continuous delivery. And all these stories are based on real world cases that happened in different organizations of various sizes. Most problems that I will mention might not make sense for you if you work in a tiny, small, 2-developer organization. Because in this case, well, most probably you don't need this DevOps, continuous delivery buzzword. It's so easy. Like, it's just implied by default. So you do software, you go to production, no human issues, no problem. It just works. However, at some point you might grow, right? All organizations want to grow. And in this case, you might really benefit from what I'm going to tell you. Should we start?
Yeah!
Yay! Okay, let's start with the first story. Lack of organizational alignment. So, also it's called shadow continuous delivery, and the term comes from shadow IT. Who have heard about shadow IT? Fantastic. So this shadow IT happens when someone does something without the without having agreement with the rest of the organization. So I'm the smartest guy. I will do things whatever I think is right without even talking to others. Right? That's what developers like to do. Right? So and here's the story. It happened in Germany about 2 years ago. So the story was simple. Once development team decided to implement continuous delivery. And there was a smart team lead who said, we are doing sprints and we deploy once in 2 weeks. That's boring. Who deploys once in 2 weeks now, right? So everyone is doing that. We need a better way. So let's start with deploying after every change. So change is ready, go live. Makes sense? Fantastic, right? Fantastic idea, of course. So there's a tiny problem. So there were the operations department, separate people in a separate room, but developers, encouraged by the charisma of their team lead, they went to this operations guy, opened the door like, you know what? Starting from today, our software will go live after every change. There was a silence in the room. Operation guys are looking back. And what they say? What did they say?
No way.
No way! They said, no way! It will never happen. And instead of having conversation, developers closed the door and left. Okay guys, you don't get this continuous delivery thing. You care about the stability. We are innovative. You don't get software development at all. So, beep! And they left. They left. Sit in the dark room and implemented something that's called deployment pipeline now, which supported deploying software once like after every change, and everything was great. So they were going live all the time after every change, but there were one tiny problem. According to the agreement with the operations guys, they had to prepare a list of changes before the sprint, right? Because operations guys, they want to know what happens on production. Makes sense? Makes total sense. But there is a way to trick the system. Let's go live after every change. But before the virtual sprint, let's just give them a list of changes that happened during this week. Very smart move. And that's what they did. Everything went smoothly. The list was there, but the software went live much more often than the list was prepared. And one day, production went down. Operations guy, they receive a call from management. Guys, something is wrong. So no money, software is broken. What operational guys do? They go to a list of changes. And what they see? Nothing. Nothing is there, everything should be working, no changes. So they try to find the problems on their side, nothing was found. Then they call developers, the responsible developer on that, they sort of. And you know what? At the end, it took them about 6 hours to recover. And the major reason was that developers didn't want to admit that they do change because they were afraid. They were not a major change, but a tiny change, but you know, it's like you do something absolutely crazy, and when the temperature is high, you don't really want to be one to blame, right? That's a danger. So they didn't want to admit the stuff at the end where the problem was obvious, so they admitted there was a problem, 6 hours to recover. And there were dramatic consequences. First of all, they missed their SLA. The major SLA, because basically there was a problem on the integration side with their major customer, and the customer was making their money. And they lost about 20 key customers, which for that company meant a disaster. It meant that they lost like most of their paying customers during this downtime. Obviously, they lost trust between management and IT because it was a startup. That was the first IT project for a business as well. So, and in this first project, you failed drastically. And there was trust between devs and ops. Slightly. Team lead was fired. And the company went bankrupt. And the company didn't went bankrupt immediately. The company went bankrupt after about like 3 months of trying to survive, to run a conversation with the customer. And instead of their customer or integration partner saying, okay guys, let's give it one more try, I know that now you can do better, they issued a lawsuit. So boom. Welcome to hell, right? Fantastic. Tiny small misunderstanding, right, in the company between devs and ops. So, what can we learn from this story? First of all, continuous delivery is a human system. It's primarily about people. It's not about tools until you pick shitty ones, right? If you don't pick shitty tools, then the major problem is human problem, organizational problem. And as every change management book says, if you want to drive a change in a complex organization, the first thing that you have to care about is alignment. You have to make sure that people see the goal. Maybe they have different opinions, whatever, but they have a shared goal, shared understanding, where are we going to? Okay? We actually have to ride the same bus, so to say. Secondly, we really have to start seeing the reason behind every denial. And that's what we suck at, really. Because if someone says us, like, no, there should be a reason for that. There's a reason. You like it, you don't like it, but there is a reason. Maybe crazy reason, whatever, but there is a reason. And your job is to really understand what the heck is going on, why someone is saying no, right? It's also about empathy, and I believe that if you have separate ops people, then it makes sense for your developers to work like a few weeks or a month as an ops guy, because a lot of questions will just disappear. You will wake up next day like a different person, really. So you will start to care, because it's really about understanding what the problems are on that side. I also believe in something that's called pair ops, right? We do pair programming as a developers. We work with each other. Why we don't do pair oping? Why don't we work together as developers with ops and we learn from each other, like for a week, whatever. And of course, like you build it, you run it, because that's how we start caring. It was mentioned today many times already. So you build it, you run it, right? And you see the consequences of your work immediately. Hopefully, there are no bad consequences. But usually that's not the case. What's interesting? There is a compromise. Fantastic word. So there's a 60 shades of gray between two deployment once in a 2 weeks and after every change. Do you see that there are shades of gray in between? Maybe once in a week. We can start with something smaller, and it will mean that it's much more easier to convince people in this way. Don't sell your revolutions to people. Start with something small that's easier to sell, right? And this is my trick, beer-driven diplomacy. This is a fantastic tool. Because sometimes, so we're talking about rationality, rational behavior. But sometimes people complain just in the sake of complaining. They don't like you, they don't like change, whatever. They have a historical background, it didn't work before in previous company. Hundreds, thousands of reasons. And you can't really solve the problem in a rational way. You can try explaining, but it doesn't really work sometimes. So what can you do? Shut up. Invite the person for a beer. Go have a beer. This person is in front of you who was complaining. Shut up and listen. No, it doesn't work, it will never work. It's you listen. Don't fight back, you listen. No. You listen to everything. Say, yeah, I agree. Say, I agree, yes, completely. And next day you come to work and the problem magically disappear. You know, it works for me. It's just a magic. Beer-driven diplomacy. So shut up, listen, don't argue, next day have a conversation, and no problem anymore. There will be a different problem probably, but the problem that you solved with a beer-driven diplomacy will disappear. Really, it works. That's an official, the most effective rule of change management, by the way. It's not official, of course. No one will write it in books, but it works. Especially in Germany and Austria, I believe so, right? It should work really well, right? One more thing that's very important. We usually try to organize, here's a operations guys, dev guys. So, okay, we want to DevOps, right? And usually we spend a lot of time organizing the efficient workflow between these two. That's what we usually do. But maybe, instead of organizing the efficient workflow between two, we can try to move operations function into a cross-functional team. And usually we don't even consider it. There are reasons for that sometimes there are no good reasons. But we can try, like quality assurance. You don't normally have a quality assurance as a separate a process, right? Why do we have operations? You can find some reasons, of course. But usually that doesn't make sense, really. And the question, when I propose this stuff, usually I get some resistance, obviously. And the reasons, and one of the major reasons is consistency. So we have many teams, right? And what will happen if all these cross-functional teams will try to do infrastructure security in their own way, right? How to make sure that we have sort of the unified approach to infrastructure. The first question comes, should we? And if we really should, then Spotify solved this problem, I don't know, 4 years ago by introducing chapters, right? So where people from different teams, they meet on a regular basis, they agree on the strategy, the vision, and then they implement the vision together, even though they work in separate teams. It just worked for them. I don't know why Spotify is that buggy, by the way. They have many problems, but this works well for them, this part at least. Makes sense? Makes total sense. Let's move on. Relying on the Tiger team. Andrew mentioned this today already. So here's the story. Fintech enterprise in Latvia, the country where I'm from. So, there was a company, fantastic company, which decided to implement continuous delivery. But since they were not ready to give their people time, they decided to hire some contractors and pick the best talents from different teams, the best talent, the more technical people, create a new team out of these people called Tiger team, core team, change team, leadership team, continuous delivery team, whatever, Tiger team. And at the same time, the rest of the people were doing this sprint, right? Sprinting, business features, like losers, right? So there were tigers and losers. Yeah, sure how it is. And in a dark room, this tiger team were playing with technologies, Docker, Jenkins, Gradle, all new fancy stuff. Oh, Go continuous delivery. No, it doesn't work. Let's try Jenkins. So it was like an R&D department inside the organization. In a few months, they built a deployment pipeline. Fancy, colors, technology, everything was there. But since this team was completely disconnected from the value stream, from someone who is actually doing work and making money, they needed to get a sign-off, right? Hey guys, we really want you to deploy through our creation. So Tiger team went to losers. Hey losers, you know what we have built? Look at this. Jenkins, Docker, pipeline, you can visualize it. You see? You see? I say, yes, we see. So what? I say, well, you see the benefits of it. Go live, deploy it, use it. Why should we? Why should we bother? Like you are playing with technology and we are firefighting with this, like doing features. So why should we? Tigers left. Then they returned back with management. And managers gently set deadline. You know, losers, maybe go to production for this new pipeline in a few weeks, because tigers say that it's cool stuff, right? Because we spend money on it. I say, okay, because overtimes were paid, obviously. Okay, we'll do. So together with tigers, and after like hundreds of changes in this pipeline, quick fixes, they finally went live. Pipeline is green, engineered. Fantastic, right? Pipeline is green, we can deploy through the pipeline. Tigers left, everyone is happy. But the drama is that the next deployment was made in the old fashion, once Tigers left. And there are two reasons for that. These guys didn't really need this pipeline at all. And they were extremely uncomfortable using this pipeline because there were many technologies they don't really need, like Docker, let's say. And these tigers were playing with Docker for a few months. Of course they are up to speed with Docker, but these guys are not, they don't know how Docker works, and now they have to use it. And at the same time deliver new functionality. Sounds like a conflict, right? But the major reason why losers say no and roll back, just in spite of tigers. Just in spite of tigers. Because these guys are playing nice stuff, they're sort of better, but we are firefighting, right? Feel the difference. So, first of all, what can we learn from it? There's one interesting thing. We have to involve those affected by change in the implementation of the change. And this is very important, I believe, because how can we build something for someone who doesn't really need it? This is weird. This is weird. And another point that overutilized slaves, losers, they can't really do continuous delivery. And tigers will be hated. And this is what happened here. I would say that the better approach would be still finding a time for a team who's doing the valuable stuff, and let them innovate. Give them time for improvement. But for some companies, it's a problem. They would rather hire someone from the outside without giving the existing team times, and it doesn't really work well. That's what happened usually. So, and what's important as well, continuous delivery is also a journey. It's not a marathon, right? And that's why all this like a consultancy, continuous delivery, introduction stuff doesn't really work well. Because it's like when consultants or external horsepower comes and implements through the pipeline, let's say, or test automation, doesn't really matter what. Eventually they will leave. And what happens next? Because someone mentioned today that there is no we are doing DevOps now, because it's a journey, right? So after a year, the stuff that you do now will be different. There will be a better way of doing things. If you can't really get there, so what's the point? So you're thinking, in the team without any external support, so you don't know how to solve your problems, which is weird. So instead of investing in some external horsepower, invest in your team and give them ability to innovate, to continuously improve, and they will probably end up with continuous delivery and some automation. Does it make sense? Makes total sense. Okay, let's move on. Newton's law of software development. This is very important. So there are rules and laws in the software development that everyone should know. Why should we know them? Because you can't really change those rules. They are there and you have to obey. So these are the constraints, right? And one of the rules that you all probably know is the Conway's law. Do you know Conway's law? Everyone, Conway's law, every conference mentions Conway's law, right? Conway's law. So listen, the system being produced will tend to have so complicated stuff, right? So let's look at the example. There was a team in Latvia, in country where I'm from. There was another team, they've been working on a large code base. Let's call it monolithic code base to stay modern, right? It was monolithic code base. A lot of code was there. And since management thought that the team is so slow, they decided, and in Latvia you can't hire developers because there are no developers, they decided to hire people in the United States. And the problem is that the team in the United States was in the completely different time zone. They've been working in California, which means that there are absolutely no time overlap. Absolutely no time overlap. Which led to a wall between those two. Because we can't talk, really. We can't talk, but we have to deliver somehow. We can't talk, but we have to go fast. And they hired an agile coach to solve all the problems. Agile coach came to the team, came to the company and said, "Bring the pain forward," he said. "Bring the pain forward," as continuous delivery says. Bring the pain forward. So basically what he implied is that like a run, and you will figure out how to solve all the problems during the way, right? So just run and we'll see. So bring the pain forward, suffer and we'll see what will happen. So the problem is that immediately after they start to bring the pain forward and run fast, the system starts to crack, somewhere in the middle. Because essentially, instead of, so in order to run fast and avoid the communication penalty, team was forced to isolate. So an isolation means that there are the knowledge silos appearing in the code, right? Basically, if they don't really communicate, so if this team introduced a bug there, they got blamed either from the UI's team because they have to roll back. At the same time, if UI's team introduced some crap, well, then Latvian team is looking at the code, oh, there is so much crap, and they don't really talk, and they don't have conversation because there is a wall. And it's not very obvious, I believe, so we don't really think enough about such a problems usually. And the message is very simple. If we rephrase and simplify Conway's law, we'll end up with something like this. So your team structure will override any architecture you have. Checkmate. That's a rule. It's a rule. It's not an idea. It's a rule. And it is there. So this is quite interesting. So, and here's a journey. What these guys did in order to overcome the problem after the agile coach left. So basically, that was the problem, right? So there were like many teams with a communication wall between them. And the first naive approach was to do this. There were people with a UI and JavaScript web stuff experience. So they extracted the UI in the separate tier, create the middleware and some DB stuff. Fantastic, and they made things even worse. Obviously, because now you have 3 teams working on separate stuff. You have to organize the flow between them, and they can't deliver a value independently. So they're like kicking each other's butts all the time, and they depend on each other and can't produce value. So it's like a half-assed teams, right? Doesn't really work well. So then finally they realized that you can actually do it a bit differently with some challenges on the UI side, actually. So you can organize the teams and architecture around bounded or the business context, which is sort of obvious. And the goal is to make sure that your architecture and team structure enables autonomous software delivery. Because we don't want to have this like dependencies, right? Dependency is something that slows us down. We want to go our own ways. That's why code sharing is also evil, right? Because you have dependency, right? So, and it's not about microservices. It's like an old microservice. No, it's about autonomy of the teams. Basically, it means that the team owns software, like technical stuff. Maybe they do operations as well. Maybe they have their own product owner and even their own budget. It's about autonomy. This is important, okay? It's very important. And here are the takeaways. So first of all, continuous delivery may require organizational change. So instead of rushing immediately, like bring the pain forward, stop and think whether you really have the structure, organizational structure that supports continuous delivery. And before rushing, maybe you need some change. And what's important is a bidirectional connection between the organizational structure and the architecture. What I see when the organization changes, we are running and changing the architecture immediately, right? So new products bubble up, and technical guys, they create new code bases, new services, whatever. That's what happened, that's okay. Organization evolves and we adapt as technical teams, right, delivery teams. But what I don't see often enough, that when the architecture changes for some non-very business reasons, maybe some technological reasons, right? We don't really impact the organization. Organizational agility is like a sort of always worse than our technical agility. And that sucks, because I believe that if you want to go fast as an organization, your technological decisions should really not only follow the organizational structure, but should really impact the organizational structure as well. And that's what we don't really do enough. Okay? And what's important again, so you can't do a perfect architecture from the first shot, right? It will evolve. So there's evolutionary architecture, right? So the organization should be evolutionary as well. Okay, what's important? Some teams have very high pain tolerance. They just suffer. You say, bring the pain forward, and they will suffer. And they like enjoy it. They enjoy it. They suffer, they boil, they cry, they swear, and they don't really improve. They just suffer. And they need this external stimulus to somehow, like, to figure out what's wrong, to see what's wrong with them, and this is important. And because pain usually leads to painkillers. And we don't really solve the problems. We try under pressure, we start solving symptoms without really looking at the big picture and seeing what's actually wrong, where's the root cause. And we have to really respect the Newton's laws of software development. They are there, and we have to know them, ideally, right? And there are hundreds of them. Conway's law is just one of thousands, hundreds of different laws. And here's one of them. How does a project get to be a year later? One day at a time. Very, very, very logical, right? So the thing is that I want to point you to a few books that I believe every software developer or someone in charge of software development should really read. This is old stuff, the Mythical Man Month. Old stuff, so many gold ideas are there. And different laws that are on the market now, but we sort of feel the consequences of not following them, but they are there. Secondly, Organizational Patterns of Agile Software Development. It's not a very popular book, it's a fantastic book about how we can organize our software development so to respect the constraints of the organization. What is the most efficient way of combining teams, people, architecture together? Fantastic book. Okay? Makes sense. So simple. misunderstanding of fundamental principles. And this is a big problem in our industry. It's not only about continuous delivery, whatever. It's all about how do we learn. Because what I see in our industry, we have this sort of very fragmented knowledge and understanding of the domain of the problem. You read blog here, you read blogs there, you read one more blog article, you watch some video, and you start doing things. Right, and this is the problem. We sort of learn a lot of practices. Do this, do that, but we don't really understand the reason and principles behind them. And this is very, very, very dangerous. And that's what I usually see when I join some team. For example, I see deployment pipelines built. Fantastic pipelines, green, fancy, technologies are there. But they are inconsistent. Essentially, I can deploy something that I haven't even tested. So there are so many holes in this pipeline, so it's completely broken. So in fact, you don't need a deployment pipeline. You need a consistent deployment model, deployment system, which can be built without deployment pipeline. You don't need a pipeline, you need the consistency, right? So you better have a consistent deployment rather than inconsistent deployment pipeline, right? Or something like this. We test data migrations, and but at the end of the day we have a production problem. So when we run our migration script, we block a whole database and transactions start to fail. Yes, of course, because you tested your migrations on an embedded SQLite database with 10 rows, right? Yes, you test this stuff, but it doesn't really make sense. I don't think so, right? Or what about this? We strive to achieve like a high code coverage. Let's say to cover everything, to automate all the things, right? Like, and you will write unit test, API test, maybe web test, whatever. However, it's about our confidence, right? We write tests to be confident, right, that we didn't break something, usually, right? If we weren't, like, TDD here. On the other side, maybe it's about finding the balance between the cost of failure. So basically, maybe it's cheaper to accept some failure at some point, a risk of like the bug passing through your pipeline. And on the other side, implementing the recovery mechanism. Same result, actually, same result. So maybe our system is not 100% covered with tests, but we can recover if we introduce a fuck-up, like a fuck-up-driven development, right? So we can achieve sort of the same by reducing mean time to recovery and mean time to detect, which is nice. And they're not replacing each other, definitely. It's about finding the right balance. But we usually test, or this, so it's about balancing. And this is my favorite. If something is difficult or painful, do it more often. That's what continuous delivery book says. Now imagine the situation. I have a brick. Large brick. I have a head, and I hit my head against the brick. Bloody face, but I still do it. It's painful, right? It's very painful. Should I do it more often? Doesn't really make sense. And here, maybe if we do something and it hurts, the problem is that we're doing something crazy that doesn't really fit our context, our organization. That's one of the reasons why something's painful. Another reason, maybe we're doing it wrong. Maybe is there another way? Maybe just stop, slow down, look at the problem, and try to achieve the same in a different way. It's not about like brute force. If it hurts, do it more often. No. And I see teams doing that. One more thing. This book was mentioned 2 times already, at least while I've been here. This is a fantastic book. I have mentioned at the beginning of this part that our knowledge is extremely fragmented. We blog, article, video, let's go, let's fly. Continuous delivery. And my personal statistics show that many people who are in charge of continuous delivery, and they didn't ever spend time on reading this book from A to Z, they do obvious mistakes. They don't see the connections between practices and the principles behind. So if you're really in charge of this stuff, go and read the roots. So you'll understand the fundamental principles behind the continuous delivery, right? It's like connecting. It's about connecting the dots. You'll have, I know this, I know this, I know that, and after reading and diving into the roots, you will make a connections, which is nice. So let's move on. Optimizing the wrong thing. Continuous delivery is about, well, moving faster, right? Want to move faster, want to produce more value to a customer faster. This is the reason. So it sounds like we need to accelerate and push more work. So what do we normally do? Let's say the hypothetical but very popular situation. You have a separate testing phase. Let's say the people who are doing testing. Developers are doing testing, but still there is someone who's doing testing again. Even automated testing, doesn't really matter. So, and developers, they produce stuff, they test the stuff themselves, but they don't test everything. So basically, someone is accepting their work, and you don't even throw over the wall. You gently pass the stuff to testing, right? Anyway, so there's someone who is accepting your work, because it's not really, you can't say that it's done, right? Because it's not tested by someone. Here's the process, hypothetical, not real, right? So we push a lot of work, push. And when you look at the value stream, let's say Trello, you might find something like this, right? So everything is in testing, because we're moving very fast, usually faster than the testing stuff, and we produce a lot of work, more. Hey, and it has we feel that we do a lot, right? We're moving fast, like, whoa, achievement unlocked, moving fast. And there's a huge problem, because nothing is actually on production anyway. So maybe, you probably know what happens at this phase, right? It's overutilization. Someone is probably here. Like, oh no, stop pushing this work on me. Because someone is overutilized. I can't handle the input that is going on me. And at this point, people who are in charge of this, they do crazy things. Because you're in rush, you're on fire, and you know what people under pressure do, right? Of course. And you start to decide what to test, what not to test, what to prioritize, and all these interesting kind of consequences bubble up. So what if we rethink our model slightly and start pulling the work instead? I'm ready, I can accept more work. I'm ready, I can accept more work. Which means that if I say I can accept more work, if I say that, there is some capacity, right? I should know my capacity. How much can I accept? It's about sort of Kanban-ish style of work. So, and you can achieve it by limiting the number of items in progress. So what I normally do when I join the teams and I see this large list is, hey guys, let's do it this way. Let's say you can take more than one item at a time. Oh, one item at a time, oh my God. We have 2 people. Yes, 2 people, fantastic. Just work on the one item and don't accept more. People say, oh, crazy, people, oh, crazy. So yes, this is crazy, but this is extremely beneficial because it changes the rules of the game completely. It means that in order to push things forward, you will have to finish existing work. It's a game changer by introducing artificial constraint. I don't say like one, it's not like a carved in stone, 1, 2, 3, depending on number of people, but limit the number of items, say it can never be more than like a 2, 3, whatever. It will lead to finishing existing work rather than accepting new. Then you start setting more constraints, let's say on development. So basically you push this overwork outside your value stream, like you push by setting the constraints. And there's a reason for that. First of all, which is not very obvious, you probably know that there's a Little's law. Who knows what is Little's law? Okay, you know because you've been on my presentation many times, right? So Little's law is a fantastic law which says that there's a linear relationship between the amount of work we have in progress, you saw that like with tickets, and our average lead time. Basically, how fast we move on average. And this lead time is impacted by amount of work we have. Simple formula, but extremely misunderstood. And here is what I have for you, a challenge. But imagine you have 32 cards in process. So this is what you work on, 32 items. And your throughput is 2 cards a day. You can't finish more than 2 cards a day. Let's say they are of the same size, doesn't really matter now. What's your average cycle time? How fast do you move on average? 16, exactly. Now imagine that I want to have a cycle time 1. I want to go live, let's say, every day. What should be my work in progress? How many items I can accept in order to sort of decrease my cycle time to 1 day?
2.
Obviously 2, right? It's not that simple as it is. It's about like stable systems. There are some exceptions to the rules, definitely, but in general, the rule is true. And this is counterintuitive, but it works this way. And what can we learn from this? First of all, we have to optimize the whole. People are saying optimize the whole, because obviously optimizing like a small part of the system can sub-optimize the whole. Makes sense. But practically, if you look at this value stream, we have to understand that in every system, exactly one constraint determines the system capacity. If someone, let's say in front of me, who is accepting my work, is the slowest part of the system, no one can move faster. It doesn't matter how many items you produce. It doesn't make sense. What does make sense? Joining and helping out to finish existing work, and then you accelerate. This is very important because we think in us what is our part of the job. Yeah, for me, it's either done or not done, and how you get there doesn't really matter. So it is very important. Secondly, like one very simple rule. If you have one completed feature, it beats like 1,000 in progress. For me, I run my like a small software development team, very small, and it doesn't really matter for me as a customer when it doesn't really make sense for me to hear, hey, we have 10 almost done items. Say what? Okay, 10. That's a lot, but for me, 0 value. What I want to hear, hey, we have this one item done. Now I can have money, I get the feedback, obviously, from the production. So this is what matters, actually. So we have to measure what we actually have done, not we know how much stuff we have in progress. But if we see at this indicator, like a 10, like in progress, hundreds in progress, it might indicate some problem as well. Let's move on. Fantastic book, Kanban. If you're a software developer, I know that you don't really like this Kanban-ish agile stuff. I don't like it too. However, there are fantastic books that will explain the dynamics of the software development to you in the simple terms, and you will know which parts of the software development pipeline to impact in order to accelerate. This fantastic book. It's actually for technical people. Fantastic. Go ahead and read. Delivering the wrong thing. I like it. Continuous delivery is about producing a lot of work, right? A lot of stuff to production. But let's read the official definition from Wikipedia. Can it be official if it's on Wikipedia? It doesn't matter. Continuous delivery is a software engineering approach in which teams keep producing valuable software in short cycles, yada, yada, yada. What we usually forget, I need more time, valuable. Valuable software. So it's not about producing software in short cycles. It's about valuable software. Valuable. Remember this mantra: valuable software. Valuable. Maybe it's not even software, but the value. You have roots value. That's your job. If you look at the common deployment pipelines, you'll see this. So, here's a deployment pipeline. Basically, there is a shit idea that you develop. It reliably goes through the pipeline, so everyone's spending time like testing, making sure tests are written, everything passed, everything is green, and then it smashes production like that, and hits the customer's face. And no one's actually happy. So the problem here is that it doesn't really make sense to spend money and time on something that is not needed or doesn't really bring a value. Usually we're got fed by the ideas from the outside. We don't really challenge the ideas back. It doesn't make sense to do. Because for me personally, so you have heard about this idea, the sort of the level of the software programmer's maturity. So how can I do it? How can I do it fine? And next level, how can I not do it? Right? This is the pinnacle of everything. You have to challenge. Should I really do this? So my point is that before we really start accelerating something, before we start moving faster, we have to understand what the value means. What the value means for you, for your customer, for your stakeholders, for your management, whatever, for everyone involved in the software delivery. So we have to become good at mining value. How to mine the value, how to understand that is really important. Unfortunately, usually you have to build something to understand whether it's valuable, but maybe you don't have to build the whole thing, right? So this is important. We have to, before we accelerate the delivery of something, let's think what we actually deliver. And you probably heard about a few terms. First of all, Genshi Genbutsu, like go and see yourself, or going to Jamba, like go in and see actually what customers are doing, how they are using our software. It's about some user says, hey, this is important. Go and see yourself. Go and check. Go and double check whether it's really important for someone. If you don't have access to customers directly, what about working closely to a customer service team to understand how customers are using your software, whether they're happy, how many bugs. Sometimes it doesn't really make sense for the idea or the requirement to come from the outside. Just build it. You, if you are a software developer, you have a magic spells. You can build something. Just build something and show it. Hey, do you like it? If someone likes it, go ahead and maybe it's a good feature and customer will be happy. So don't wait for someone to come up with a good idea. Build it, show it to customers, and have a discussion. And the tragedy is that I see many teams and software developers and operations who are never using the software that they build. And this is crap, because even if the project is fantastic, people don't use the project that they build. And how can I build something interesting, inspiring, exciting if I'm not the customer of software? I don't really know. So go ahead and try becoming customer of your software. It will make your sort of daily routine much more interesting, I think so. So the point is that we can essentially maximize outcome. So we have to maximize outcome, but minimize output. This is a very important point, because have you heard the notion of vanity metrics? Vanity metrics. So from Lean Startup, vanity metrics. So metrics that shows that you do a lot, and it's sort of usually you do a lot, but it means nothing. So you may produce hundreds of features with zero value. You're just wasting your customers' time and money, whatever. So you can even bring a negative value, right? So it's not about the output, how much you do, but it's about what you do and what impact you make. So don't measure your output, measure the impact, the value. How to measure it? You have to decide yourself. This is the toughest part, essentially. But the mindset is important. Okay? Technical obsession. Steve Wozniak, technical obsessed guy. So, here's a story. Happened in Australia, in a very famous company. And there's not many famous companies in Australia. Right? So, and the challenge was implementing deployment with auto-scaling. And they had a stack, AWS and Capistrano. It's boring, right? AWS, everyone is on AWS. Capistrano, who knows what is Capistrano? Yeah, who cares about Capistrano? There's no Dockers there, right? Something is definitely missing. Definitely. So, it sure would be fun to use Docker. Because everyone's using that, right? At least what you read from internet. Everyone's using Docker now. Only our team is not using Docker. And it opens the opportunities in future if you run everything in a container. So what they did, they instead of like using their existing stack, they installed CoreOS because you want to have a native, pure container-based operating system, right? It's so puristic and so CoreOS, yes, of course. But it's not enough. You want to program to your laptop, you want to program to the data center as you program to your laptop, right? What's the difference, data center or laptop? Put a mesos, right? So everything is a black box, just deploy somewhere and it will somehow scale and whatever. And nowadays it will be Kubernetes probably. So Mesos, but that's not enough because Mesos doesn't run long living processes. You have to install Marathon on top. Which is also run in container. So container, fantastic, very nice, especially when you put it in your CV. CV is like you are the most demanded DevOps engineer on the market after that. DevOps engineer, right? That's a joke. Still, there are still, even if you know this, you're not DevOps engineer, right? So basically, they put this all stuff on production, and 1 month later, Hydra was born. So the monster. So what is Hydra? Hydra is a water monster with reptilian traits. What's interesting? It possesses many heads, more heads than the base painter could paint. So basically, it brings more problems than you could imagine. And for each head cut off, it grew 2 more. So you solve a problem, and 2 more bubble up. So that's what they have built. And basically, they became slaves to their creature. So they have created something they start to be too afraid of. My son, I'm afraid of you, right? So something like this. And the timing was not very good because they were having this some new products moving to SaaS model, and it was not a very good time to change to move the infrastructure to such a nice set of tools. So after about 3 months long war, team suffered many losses and capitulated. So they tried to figure out how to manage production with this Hydra, but they decided to back off. And it took them 1 more month to move back to old and simple stack. So they invested time in Hydra, and somehow you have to move back, right? So you spend time on bringing Hydra, then to roll back a few months, and only just 2 weeks to achieve the initial goal with Capistrano and AWS. Do you understand that that sucks? That sucks, right? And here's what I have for you. The major takeaway of today. Here's the golden rule of software development. Golden rule, and you have to know it. So, you can put any trendy solution here. Give me a trendy solution. Give me a trendy solution. What's trendy now? What's trendy now?
Docker.
No, Docker is not trendy. Everyone is using Docker. We know that. What's trendy?
Serverless.
Serverless! Serverless is like teenage sex. Everyone is talking about it, but few have actually done it. True? It's true. Give me another. Give me another tool, framework, whatever.
Unikernels.
Unikernels. Just unikernels are like teenage sex. Everyone is talking about it, but few have actually done it. And it works again. You see, so it's like a theory of everything, like axiom, right? You can't really argue. It just works. So think about it. In fact, even if everyone is doing this, doesn't mean that you need to, right? Because first of all, there's the law of leaky abstractions. You probably heard about the law of leaky abstractions. That abstractions are leaky. The idea is very simple. It might sound very romantic to simplify your life, developer's life, by picking some tools that are sort of like a hiding the complexity behind. But at some point there will be a challenge, a problem. Hey, 5 more minutes. At some point there will be a problem somewhere. And you will have to understand all the stack all the way down. Because abstractions are leaky. For a happy pass, everything works always, especially in documentation or in the speech, like a super scalable, powerful, infinitely scalable solution, la la la. You put it on like a, I don't know, simple application works. Once you start scaling, it starts to leak, and you have to understand all this stuff, and it hurts. And usually you can't. The problem is usually you can't. Because something is written, I don't know, in C++, or some other interesting language that you don't use. There's also a term by Neil Ford called complexity tax. So complexity tax is an extra cost that you pay for accidental complexity introduced by a tool that does more than you need. Think of Jira. That's why I don't use Jira. Because you pay complexity tax. You don't need all this stuff around. You just need to ticket, something. Maybe you need it, but most of us don't. And I have one more hint for you. Especially if you work in this environment where there are crazy hackers that want to implement all the fancy stuff available on the market. There are hacker teams. And usually you have to slow them down. Some companies need more innovation, some need to slow down. And here it is. If you write exactly, if you take a pen and sheet of paper and write exactly what is about the current stack that makes solving the problem expensive and difficult, at some point you can't really write it. Because most problems can be solved with the existing stacks that you have. Maybe it's not fancy, maybe it's not modern, but it works for you. And if you calculate the money that you invest on like changing the whole stuff, instead of improving what you have, usually you stick with what you have, which is rational. So, and it's about overproduction in development, right? So it's like we don't want to overproduce, we want to solve a problem in a concise way, right? So think about it. And the last one is giving up too early. What I usually hear from people who step on this continuous delivery path: I don't keep up with testing. I don't keep up with testing. Our tests are so slow, people say. Of course they are slow. Of course they're slow because there's a bunch of tests that test everything. They're not somehow segregated, and you can't really trust your tests. They are there, they are running, but you can't trust because if you deploy, you still can introduce production problems. So maybe you can rethink the way you test. Or working in trunk is stupid and dangerous idea, or work in the main line. Of course it's dangerous because again, you don't trust your test, you don't know how to continuously integrate, you don't know how to organize your work in a small chunk so to avoid the conflicts with others. Of course it's dangerous, right? Deploying is so annoying. Yes, if you have a flash drive and you carry it to the ops team, yes, it's quite annoying. If your deployment is a press of a button, it's not that tough. Or like this. You really want me to talk to security officer? It's very famous in large organizations. Yes, not all security officers that bad. So, and the famous top one, it doesn't work for us. Because we're so special. We work in the company and no one ever solved the problems that we have. No one ever did that. Our company is so special. Of course it is. So, the bottom line is that people say that continuous delivery causes so many problems. There's so many problems with continuous delivery. We are good enough with what we have. In fact, this is completely wrong. Can I believe that it actually reveals problems? Because once you start putting a pressure or something, you see the weak part in your workflow, and these places start to crack, right? So it reveals many problems. There are obstacles, hundreds of them. And before you take your sword and run and fight, you need some motivation, right? And inspiration, because it doesn't work for us, it doesn't work for them. So let's get some inspiration from fantastic books. First of all, Lean Enterprise. Written by Jess Humble and a few other guys, but Jess Humble is the author of Continuous Delivery, the original book. And Lean Enterprise is a book about continuous delivery and DevOps in the large organizations. How large organizations are tackling this, like a continuous delivery at scale. Because there are a lot of unique problems, but it's possible. You go there, you see what companies are doing, you say, oh really? We don't really have a problem. It's so simple in our environment. Learn from this. Also, it's about change management. You need to know how to manage change. You need to know how to manage change. And there's a book by Jürgen Appela, How to Change the World. In fact, you don't really need to change the world. Maybe you just have to change your tiny organization. And maybe someone already did that. Or maybe you can just start by changing yourself and the way how you do the work. And I would like to thank you, my friends, for your attention. And that's all I have today. Thank you.